always the largest side. So now let's set up our problems to identify these types of triangles. So we know that C is going to be equal to 10, so I'm going to start with 10 squared box 4 squared plus 3 square roots of 3 squared. And you'll notice I put this in parentheses because there are two parts there. And when you type it in your calculator, make sure the parenthesis is not underneath that square root sign and the squared is on the outside of the parenthesis. So if we evaluate this, we would get 100 on the left side and we would end up with 43 on the right side. So in this case, our C squared is bigger, which would make this an obtuse triangle. And on the test, you have to show these steps, otherwise you won't get credit for this problem. Our next example, C is going to be 9. So I'm going to start with 9 squared box 3 squared plus 7 squared. And we're going to evaluate that, and we have 81. And we would get 9 plus 49, which would be 58. So in this example, again, we do have an obtuse triangle because C squared is bigger. But if C squared was smaller, it would have been acute. And if they're equal, it's right. So make sure you have those notes so you can review them before the test on Monday. And next, we have our special right triangles. So our first one is a 30, 60, 90 triangle. And there are two equations that you need to remember for a 30, 60, 90 triangle. And these are things that you're going to want to have memorized for the test. So our longer leg is going to be equal to our short leg times the square root of 3. And our hypotenuse is equal to the short leg times 2. And when you're labeling your triangle, the short leg is always opposite of the 30-degree angle. And the long leg is opposite of the 60-degree. And we already know that the hypotenuse is opposite of the 90-degree angle. Once you have the equations, you're going to look at what information they give you. So which side length is represented by a number. And in this case, it's our hypotenuse. So that tells us we're going to start with our hypotenuse equation. So we know the hypotenuse is equal to 16. And the short leg is represented by y. So we're going to plug y in there. And we're multiplying this by 2. So we're going to do inverse operations to solve for y. We'll divide both sides by 2. And we'll get 8 equals y, which is one of our answers. And we know that that is representing the short leg. Now that we have that information, we can go ahead and solve for the longer leg. And in our picture, the longer leg is represented by x equals, we know the short leg, we just found that, is equal to 8, and we're multiplying that by the square root of 3. And there's nothing that we can simplify here, so our final answer is just going to be 8 square roots of 3. And that's your answer. Our next type of triangle, we have a 45, 45, 90 triangle. And there are two equations you're going to want to memorize for this one. One is that our leg is equal to our leg, and the hypotenuse is equal to the leg times the square root of 2. Once you have that, you can start filling in information. So let's use the first one, our leg and our leg. We have 8 and x for both of those, so right away we know 8 is equal to x. Then we need to find our hypotenuse. So for that one, we're going to have y equals our leg, which we know is 8, times the square root of 2. So this one we really didn't have a lot of work to do. We just plugged in numbers to get 8 square roots of 2. Our next example, you're going to see this one has 2 triangles with it. And you're going to want to do these problems one triangle at a time. So let's start with the triangle where they give us a number for one of the side lengths, and that's going to be this triangle here, which is a 30, 60, 90 triangle. So to start off with, I'm going to start by writing the two equations I know for a 30, 60, 90 triangle. So that's going to be, we know the longer leg equals the short leg times the square root of 3. And the hypotenuse is equal to the short leg times 2. So now let's start solving for information. I'm going to make this side a W because it doesn't have a variable, but that side length is going to help us in our final answers. So we're going to find all three sides. So I'm going to start by labeling. We have our short leg, our hypotenuse because it's opposite of that 90-degree angle, and our long leg here. So let's start solving. Our long leg is represented by W. Our short leg is 9. Square roots of 3. Now that's not one of my final answers, but it will still help us later, so that's why we found it. Next, we're going to figure out what our hypotenuse is. So that's Z equals our short leg of 9 times 2, which will make Z equals 18. Okay, so now we have found all three sides in this 30, 60, 90 triangle. I'm just going to write those down on here so we can see them. We know our hypotenuse is 18, and this one is 9 square roots of 3. Now we're done with that triangle, the yellow one. We're going to move on to our second triangle and figure out the missing side lengths there. So now we don't need anything else from that yellow triangle except for the one side that they have in common. Which, looking at this triangle, the blue one, that side is going to end up being our hypotenuse. And this one is a 45, 45, 90 triangle. So in that one, there are again those two equations that we wanted to memorize, that the leg is equal to the leg, and the hypotenuse is equal to a leg times the square root of 2. So in this one, we know the legs are going to be x and y, and that just tells us that x and y are going to be the same value. And then we're going to use our hypotenuse of 9 square roots of 3 to figure out what those legs are equal to. So in this equation for the hypotenuse, you can use x or y because we know they're the same thing. And now that we have our equation, we can go ahead and get x by itself. To do that, we'll just divide by the square root of 2 on both sides. And when you have this, remember you can't leave the square root in the denominator. So we know that x is equal to 9 square roots of 3 over the square roots of 2. But because we can't leave that square root of 2 there, we're going to multiply both the top and the bottom by that square root sign. And by doing this, because both of these numbers are under the square root sign, we're just going to multiply those together, which means the 9 stays the same in the front, and that'll become 9 square roots of 6 all over 2. And that is our x value, which we already know is going to be the same as our y value. And there are our answers. So now let's move on to our next problem. Number 8. We're going to use the triangle to express each trigonometric ratio for the given angles. So this first one, first two, we're looking from angle A. So I'm going to label these from angle A. We have our opposite, our adjacent, and we have our hypotenuse. Now let's start labeling. So we're using our SOHCAHTOA. And these are all ratios, which means our answers are going to be fractions. And if we have the sign of A, we know sine is opposite over hypotenuse. So our opposite is 5 and our hypotenuse is 13. And then if we do the cosine of A, that's our adjacent over our hypotenuse, which would be 12 over 13. And now you'll notice we are changing angles. We're now looking from the perspective of angle C. So now our opposite is going to be 12 and our adjacent is going to be 5. So those two are going to switch with each other. Next, we're going to be finding the tangent from angle C, which is opposite over adjacent. Oh, I wrote that wrong. Sorry. That is supposed to be an A, adjacent. So for this, we would have 12 over 5. And then we're going back to, sine, which is opposite over hypotenuse. So we'll have 12 over 13. So all of these answers are fractions, and you don't need to use a calculator for them at all. Okay, so looking at our next problems, we are going to use right triangle trigonometric ratios to solve for x, and we're going to give all answers rounded to 4 decimal places. And we also need to show all work on these. So for these, the first thing you're going to do is label your triangle from the angle they give you with your opposite and hypotenuse and adjacent. So looking at what they have, we're looking for x, and we know that the hypotenuse is 18. So looking at SOHCAHTOA, we have opposite and hypotenuse, which would be O and H. So we're going to be using sine. When you write your equation, you're going to start with the function, and then you're going to put the angle. So sine of 28 equals the fraction. So our fraction is opposite over hypotenuse, which would be x over 19. Now that we have that, we're going to get x by itself before we put anything into the calculator. And that gives us 19 sine of 28 equals x. And this is what you will go ahead and type into your calculator. If you want to try it out to make sure you get the right answer, you can. And this one, when you round, it does change quite a bit because it ends up being about 8.9199. And I think it was like 7 here. And we needed to round to 4 decimal points. And when we do that, this 7 causes us to round that up to a 10, which would cause this to round up to a 10, which would cause that to round up to a 2, which would make this 8.9200 is about equal to x. I don't think the rounding will be quite that complicated on the test, but it's always good to do those practice problems just so you know you are still working on improving those skills of rounding. So now we're going to do those same steps on our next problem. We're going to go ahead and label our triangle from the angle they give us. So we have our opposite, adjacent, and hypotenuse. And looking at the ones that we're looking for and the one they give us, we have adjacent and hypotenuse. In the SOHCAHTOA, adjacent and hypotenuse is going to end up being the COA, so cosine. And we can go ahead and write our equation of cosine of 21 degrees equals x over 26. For this one, to get x by itself, we'll multiply both sides by 26. And then this part is what we can type into our calculator to get x. And when you do that, if you want to try it out to make sure you're doing it correctly, you should get 24.2731. And that would be our final answer for this one. Our next problem, this one we have tangent of B equals 20 over 37. And we're going to find the measure of angle A, and we're rounding to 4 decimal points. So to do this, to find an angle, you're going to be doing the inverse value. So this one we're going to do tan -1 on both sides. And when you do that, the tangents on the left simplify, and we're left with angle B. And then on the right side, that's what you're going to type into your calculator. So tangent -1, or the inverse tangent, of 20 divided by 37. And when you do that and round to 4 decimal points, you'll end up with 28.3930. And I do recommend trying to type some of these into your calculator so you make sure that you know how to do it for the test. All right, number 12, we are going to be solving a triangle. And one thing that's important to know is when it says measure of angle, these are talking about angle measurements. And when it just says a variable equal to, these are our side lengths. So right away, we should know the measure of angle Y because that one is our right angle. So right away, that is our 90-degree angle. And then looking, they give us 2 sides in this triangle. So right away, we should go ahead and find that third side so we have all 3. And this is very similar to the first problem we did on this. We're looking for a third side of a right triangle. So we're just going to use Pythagorean theorem. So A and B can be on either side of the right angle. C is always across from the right angle. We'll have 9 squared plus 12 squared equals C squared. And if we were to add those two together, we would get 225 equals C squared. Or in this case, Y squared. And then, excuse me, we would take the square root of both sides. And remember, you should type them into your calculator first to see if it is a perfect square. And if not, then you do the factor tree. And this one, we would end up getting the exact answer of 15 for that missing side length. And our next step, we need to figure out the angles, which right here, that's what we do to find angles. We're going to be doing our inverse functions. So let's go ahead and pick one angle. I'm going to start with angle W because it's at the top of my list. And we can use any of the 3 sides since they're all whole numbers, but I'm just going to use the 2 they give us to start with. So from angle W, we have our opposite side and our adjacent. And if you look at SOHCAHTOA, opposite and adjacent is the TOA part. So when we set this up, we're going to do the tangent of angle W equals 12 over 9. And just like we did on our last problem, we'll take the inverse tangent on both sides. And that will tell us that W equals, and we were told around 4 decimal points. So we're going to get about 53.1301 degrees for angle W. And then we can do the same thing to find angle X. We can do the tangent of X equals 9 over 12 this time, and then we take the inverse of both sides. And by doing that, we're going to get X is about equal to 36.8699 degrees. And that's our last step for solving for a triangle. You just have to find all of the missing measurements that they give you. The last few problems are all going to be word problems, so you want to make sure you read each problem carefully and show all of your work so that you get full credit. All of these somewhere in the problem are going to have a right triangle. So if you're stuck, make sure you just start with that right triangle. So our first problem, number 13, how far away from the base of a house do you need to place a 15-foot ladder so that it exactly reaches the top of a 12-foot wall? So if we have our house and we have this wall over here, we are going to be leaning a ladder up against it. So there's my ladder, leaning up against the house. Remember, the house and the ground always are going to form a right angle. And they want us to solve for how far away from the base of the house, which would be down here, do we need to put a 15-foot ladder. And it reaches the top of a 12-foot wall. So now that we have all of that labeled, we have a right triangle and we're looking for a missing side. Again, that leads us to Pythagorean theorem, which this isn't new, so hopefully we should get it. A and B can be either the legs, and then C is the hypotenuse. So 12 squared plus x squared equals C squared. And we know that C is equal to 15, so we should put that in. Use your calculator to figure out these values if you don't have them memorized. And then our goal is to get x squared by itself right now so that we can take the square root. And when we do that, we're going to get x squared equals 81. And when you take the square root of both sides, we get x equals 9. And don't forget your labels of feet. The hardest part is making sure you get the picture drawn accurately so you have the right triangle labeled appropriately. Next, a ramp is used to load a suitcase on an airplane. If the cargo door is 7 feet from the ground, so let's start by drawing a picture. We know we have a ramp that leads up to a door that is 7 feet above the ground. Okay, so now we have that information drawn right away. It also tells us they have an angle formed by the end of the ramp and the ground that is 25 degrees. So that's going to be down here because this is where the ramp meets the ground. They want us to figure out how long is the ramp, and the ramp is here. So that's what we're looking for. So this one we're given an angle and one other side length. We're going to have to use some trig for this. So whenever you're only given one side length and one angle, you should know that you are going to be using sine, cosine, or tangent. Okay. So this one has opposite and hypotenuse, so we're going to set it up using sine. So we'll do sine of the angle 25 degrees is 7 over x. And we're going to cross multiply to get x by itself eventually. In this one, that means we're going to have to divide by the sine of 25 on both sides. And we can type that into our calculators. And you might want to do that just to make sure you know how to do it. And you should get about 16.5634 feet is equal to x. And that is how long our ramp is. Okay, we just have 2 more problems to go through. The next one says a person starts 60 feet away from the base of a tree. And you probably already have a triangle started on your paper. Mine isn't here, so I'm starting from scratch. So from the base of this tree, I know I have a right triangle. The person is 60 feet away from it. The angle of elevation to the top of the tree from this point is 10 degrees, which would be that angle in the bottom left corner. Next, it says they walk 10 feet closer to the base of the tree. So I'm going to put a point there, and I know that this length here is 10 feet. And of the 60, we've used 10 feet, so that means there's 50 feet left. What will be the new angle of elevation to the top of the tree? So we have another line going here, and this is what we're looking for. We're going to round our answer to the nearest tenth. So looking at this problem, we have two triangles. We have the triangle on the outside here, and then we have a triangle on the inside of that. Oops. Right there. So between the two triangles, you should notice that they both share this side right here. And because they both share that side, we're going to set up two equations using that side of the triangle so that we can solve them by using substitution. So looking at our blue triangle on the outside, we're going to set up an equation using the opposite side and the adjacent side of a triangle. So that tells us we're going to be using tangent. So our first equation set up is going to be tangent of 10 degrees equals h over 60. And we can get h by itself by multiplying both sides by 60. But we're not going to type this into our calculator quite yet, because our goal isn't to find h, our goal is to find x. So for now, we're just going to keep that equation the way it is. 60 tangent of 10 equals h. Now we're going to move on to our yellow triangle. And we're going to write another equation using that h over here, which is the opposite side. So this one, we're going to do tangent of x, because that's what we're looking for, equals h over 50, because that's the length of the yellow triangle base. This equation has two different variables, but we know that h is also equal to 60 tan of 10. So we're going to replace the h with that value. So we know tangent of x is going to equal 60 tan of 10, and that's going to all be over 50. Now we have enough information to figure out what x equals by taking that inverse tangent of both sides. On the left side, these simplify with each other because they're reciprocal functions, and we would get x equals about, and then we would have to type that right side into our calculator, and you should get about 11.9 degrees. And this one, they did tell us to round to the nearest tenth, so that's why it's only going to 1 decimal point. Okay, we have one last example. And this one says Jaden is flying a kite and lets off 275 feet of string. So I'm going to start by drawing my kite over here. It's always got that tail going off of it. There we go. And we know that that string is 275 feet. There's Jaden. And they also tell us the kite is 150 feet above the ground. So here to here, that is 150 feet. And assuming the string is straight, what angle does the string make with the ground? So here we go. And we're looking for this angle over there. So again, we have side lengths and we're looking for an angle. We're going to need our SOHCAHTOA. And looking from this angle that we're looking for, we have our opposite side and we have our hypotenuse. We're going to be using sine. Setting up our equation, we're going to have sine of x equals our fraction of 150 over 275. And because we're looking for that angle, we are going to be doing the inverse function. Those simplify. And we're left with x equals, and we'll type that into our calculator. And again, we're rounding to the nearest degree for this one. So our final answer is going to be 33 degrees. If you have any other questions, just let me know. I will have the answer key posted for you for the version 2 and the version 1, so you have all of those practice questions to review with. Have a good weekend.